Hello, everybody. This week we're going to begin by talking about elements and what an element is. And we're going to skip ahead a little bit in some of the ideas that we're going to cover in this course. I just want to kind of put them in your guys' heads so that you can kind of percolate on them before we cover them in a little bit more depth next week. So, the first thing that I want you guys to realize is that all matter is made of atoms. They are the basic building blocks of everything. They're the smallest indivisible unit that a bulk material is still going to have the same properties. If I go any smaller than an atom, then it is not going to have the same properties as a bunch of the atoms put together. Atoms themselves are made out of subatomic particles. These include protons, which have a positive charge, neutrons that have no charge, and electrons that have a negative charge. There are a finite, so limited number of permissible atomic configurations. We can only arrange protons, neutrons, and electrons in a limited number of configurations that are going to work. And these are broken up into different elements depending on the number of protons the atom has. So let's look at a little example here of the most simple cases that we have. We could have one proton, and it's going to be right in the center of our atom in something that we call the nucleus. And with that one proton, we're going to have one electron. It travels around the nucleus and something that we call an orbital. And you can see that there's a positive charge on the proton and a negative charge on the electron. So we have one negative charge, one positive charge, and that gives the whole thing a neutral charge. 1 plus 1, 1 minus 1, and we get to 0. So if we have one proton, we call that hydrogen. And for every different element, we're going to have a symbol that we use to kind of abbreviate it. So the one for hydrogen is just a capital H. And we can put these two numbers beside it here. So there's one that is a superscript and one that is a subscript. The superscript is called the mass number. And this is going to be roughly equal to the number of protons plus the number of neutrons. So since we only have one proton here and no neutrons, the mass number for this guy is going to be 1. And then we're going to have the subscripted number there, and this is the atomic number, which is going to be equal to the number of protons that we have. So here you can see a different form of hydrogen. We're going to talk about what that is later, but it's known as an isotope of hydrogen. And this one has an extra little neutron in it. And you can see that when we wrote the symbol for that, it has a 2 here and a 1 here because there's an extra neutron. But it's still hydrogen because it still only has one proton. And the number of protons decides what element it is. Here we have an example of helium. We have 2 protons in our nucleus. We have 2 neutrons in there. We get a mass number of 4, and we get an atomic number of 2. And the symbol to abbreviate helium is a capital H with a little e. So, how many configurations are there? They are represented on the periodic table of elements, and we're actually to a point where we've filled out this bottom row where all of them are radioactive and only have been made experimentally in like particle accelerators and stuff. So I don't know. Maybe we've got them all really at this point, but even out here, they're pretty unstable. And you can see that there's a lot of things you might be familiar with here. We have, hydrogen. We all know what that is. We've got Fe, which is iron. We've got Ni, which is nickel. Here we have Au, which is gold. Ag, that's silver. And then some other ones that you might not be so familiar with, like Os is osmium. W is tungsten. HF is hafnium. And down here we have some praseodymium, neptunium, polonium, and some other more exotic sort of elements. So, I said that all matter is made out of atoms, and that all atoms, each individual different atom, makes up an element. But obviously there are more forms of matter than just what are on this table. So how are we getting to those other forms of matter? In order to do that, we have compounds. And compounds form when the electrons on atoms interact with one another and the atoms stick together, forming a chemical bond. So here I have an example where I have a little lithium atom, and I drew it a little bigger than the hydrogen, and that was actually very purposeful. Lithium is larger. It's a larger atom than hydrogen. And then their electrons are interacting, which I am illustrating as a line here that is called the chemical bond. And together with this chemical bonding, they form what is called a molecule. In this case, it would be lithium hydride, which is one other form of matter that we have. So all the other forms of matter that aren't on that table are just combinations of chemically bound atoms all put together. So your body, for instance, is made mostly of carbon, hydrogen, and oxygen, some sulfur, some phosphorus in there, and they are all bound together in many different intricate ways that make up all of the different materials that are inside your body. And molecules will take on different shapes depending on the electronics, the way that the electrons are arranged. For instance, this is a water molecule. You can see that it is kind of this bent shape where we have an oxygen atom here and then two hydrogens that are not necessarily right across from each other, but kind of skewed like this. And that leads to different properties that we're going to see of water. So a little bit of language here. Any sample that contains only one type of atom or only one type of molecule, we call that a pure substance. Which leads us to mixtures. Mixtures are when two or more pure substances are combined together. Okay? And mixtures come in two different types. They can be a homogeneous mixture. This is one that has a consistent composition. So everything inside of that mixture, that there's the same amount of each component in any little piece that you took off. So an example of this might be like a glass of water with sugar dissolved in it, right? If you took out just a small portion of that water sugar mixture, you would have, no matter how many times you did it, each one of those samples you took out would have a consistent amount of sugar and water in it. They would all be the same. And the other type of mixture is a heterogeneous mixture. This is one that has an inconsistent composition. So that means that if you drew out a sample from it, and then you drew out a second sample, they may not have the exact same composition. So an idea of something like this might be something like concrete, right? It has stones in it. It has other minerals and stuff in it. So if you took out a chunk of concrete from the road, you may get one piece that has more stones in it or different kinds of stones in it than another. They wouldn't necessarily be exactly the same. So while pure substances have very fixed chemical and physical properties, the chemical and physical properties of mixtures are more varied. And we're going to see that later in one of the labs. We're going to be trying to separate the components of a mixture. The different parts of the mixture may have different properties that we can use to separate them.